This discussion is dependent on understanding how DD coils work. If you have not viewed the YouTube video on understanding and using DD coils dated 19 January 2018 on the Mad Dog Coyote channel, you really need to view it before continuing with this discussion. With that information, we can apply what we learned there to developing a methodology for pinpointing with the metal detector. But before that, we need to understand the difference between normal search mode and pinpoint mode. In search mode, the detector is measuring the relative change in the impedance of the coil signal moment by moment. By that, I mean it reports the relative change from one time interval to the other. There must be motion of the target within the coil field to register an audible response in search mode. If the target is stationary in the coil field, it will not be reported. In pinpoint mode, the detector creates a disturbance or impedance baseline at the time the pinpoint mode is entered. It will then report changes that occur relative to that fixed baseline as a change in volume and frequency. As you can guess, it is important where and when you enter pinpoint mode. If you are precisely over the target and you enter PP mode, you may not hear anything, even when you move the coil off the target. The disturbance baseline was at the highest over the target, or directly over the target, and any movement off of that directly over it will only lessen the signal. It cannot report anything less than the PP baseline. That is why sometimes the pinpoint signal is very narrow. You entered pinpoint mode very close to the target, but not directly over it. That leaves a very small area to report the difference, which is small. This is why the following instruction appears in the MindLab eTrack manual. Once the approximate target location is known, move the coil to one side of that location and press pinpoint. Then slowly sweep the coil over the target location. They do not say how far off to one side is enough. You do not want to move it so far as to place an outer coil over the target. In the prior video, we saw that this will produce a false pinpoint on a shallow target. I would recommend that you move it off to the center of one of the side coils. This instruction will prevent the pinpoint mode from essentially blanking out or becoming too narrow. The importance of this instruction cannot be emphasized enough. Now that we understand the difference between search and pinpoint mode, we can formulate a pinpoint methodology. The first step in pinpointing is to initially identify a target in search mode. You hone in on a target by oscillating the coil over a target on the coil center line. You all know this. At this point, we know the target is very close to center line. But we want to be more precise. Make a mental note of where the line is and offset the coil to one side. Then enter PP mode and pass over the previously detected center line. The pinpoint mode should allow you to more precisely locate the line the target is under. Once this is done, we need to identify where on the center line the target actually lies. One method is to heel or toe off the coil while in pinpoint mode. This will give you only an approximate position of the target on the center line. I say approximate because it is impossible to determine the exact location with this method. Garrett addresses this issue in their AT Pro user manual with the following dialogue. Some detectorists using DD coils prefer to pinpoint off the tip or tail of the search coil. I refer to this as, toeing off. Press and hold the pinpoint push button and sweep the search coil side to side to center the target, the point where the strongest audio response is heard and the maximum signal strength is displayed on the LCD. Then pull the search coil slowly towards you while noting the target signal. Once the target signal drops off, both audibly and on the LCD meter, shallow targets should be located immediately in front of the search coil's tip. Deep targets will be under or just under your search coil's tip. This is because the conical shape of the search coil's detection field begins bending in slightly as the depth increases. The problem with this method is that it is highly dependent on target depth. As you need to check where a shallow target drops off on the center line of your specific coil and detector. You need to do this before you go out and do it, or else you're not going to know. This point is not universally constant across all coils and detectors. The drop-off point also varies with the depth of the target. The 90-degree pinpoint method is by far the most accurate. Of course, multiple targets can complicate this process. Make a mental note of the target location and mark it in some manner, i.e. a divot, poker chip, golf ball marker, stick your trowel on location, etc. It is very easy to get distracted and lose track of the exact location. Being off by several inches can lead to an empty hole, especially if your pinpoint was not that accurate to begin with. So let's take a look at what the toe-off method really looks like and why it's not that accurate. What you just saw was a pinpoint drop-off for a silver dime at the coil surface. The frequency is quite high and the drop-off point is further inside the coil than where Garrett said it would be. However, this is not a Garrett coil or detector. It's a Minelab E-Track using a Nell 17 by 15 inch coil. You need to check to see where your coil drops off if you use this procedure. Now let's see what happens when the depth is 3 inches. I use a Pop-Tart box to maintain the distance. As you can see, the target depth changes things quite a bit. The frequency is much less, the pinpointing is less precise, and the drop-off point varies from well inside the coil to well outside the coil. From these clips, we see that the toe-off method is not that accurate or reliable. However, I do it to get a more limited area where the target can be. It will normally be somewhere between the end of the coil and the center of the coil, as opposed to somewhere along the entire coil center line. It reduces the possible location by more than 50%. Now let's look at what a toe-off looks at when the dime is about 6 inches in depth. Now let's look at what happens when we enter pinpoint mode too close to center line. As you can see, the response area gets more compressed than if the pinpoint mode was entered farther away from the center line. Now let's try and simulate entering pinpoint mode directly over the target. As you can see, I was not quite able to get the target exactly over center line, but the response zone was extremely narrow. If I had managed to get it exactly over the center line, it probably would have blanked out and you wouldn't see it at all. There's one thing of note. The frequency increases the farther the target is from the coil center. So if you are pinpointing and the frequency is very high, you know it is probably closer to the outer coil than the center of the coil. So let's review this process using our high-tech coil graphic aid and see what we can conclude. I also forgot to bring up one other point. A frequency for a target, let's say at 1 inch, is going to be much higher than the same target at the same position in the coil, let's say at 6 inches. So the frequencies drop off with depth. Don't you just love high-tech tools? What we have here is representation of a coin. And we're going to move our trusty coil in, and we're going to be in search mode, and we're going to be beep, 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 beep. We got our center line, so we're doing pretty good there. So now we want to go into pinpoint mode, so we're going to take it off to the center of the outside coil, go into pinpoint mode, and then you're going to see the frequency start increasing. Back and forth. And we got that. Now we're going to do a toe off. It's going to go. Okay. Well, we don't know where the target is at this point. It could be anywhere from here to here. But that's a good place to start. So then while remaining in pinpoint mode, we're just going to rotate it out here. Right? And that'd put it about out in the middle of the coil we want. And then we're going to approach it this way. It's going to. And at that point, in the center of the coil, that's exactly where the target's going to be. So let's review what we have covered today. Successful metal detecting consists of searching, pinpointing, hole digging, and hand pinpointing skills. Each one of these skills is critical to successful metal detecting. If you're weak in one skill, then your recovery rate will suffer. Hopefully your pinpointing skills will improve after having watched this video today. Remember, in pinpoint mode, the higher the frequency, the closer the target is to the coil. Make sure you do not enter pinpoint mode too close to the target. And as always, mark your target after pinpointing. The next video to be released will cover hole digging. See you then.